This is a video based on the experiment of deflection of a simply supported beam made by Group 2. Firstly, we're gonna explain the steps for the first objective, which is relationship between beam depth and deflection. The thickness and the width of the three beams were measured and recorded. The die gauge was positioned at the midspan of the beam to measure the resulting deflection. The die gauge reading was set to 0. A load starting from 1 Newton was placed on the load hanger. Then, repeat all three steps for each beam. With each beam, repeat the measurement of the deflection 3 times to get an accurate reading. Next, for the second objective, which is relationship between beam specimen span and deflection. Firstly, use the same setup as the first objective and record the deflection for 1 meter span. Then, change the span distance to 0.8 meter and record the readings. Repeat all these steps with distance 0.6 meter and 0.4 meter.
The tools we used were vernier caliper, 3 different beams, a dial gauge, load ranging from 1 Newton to 6 Newton, 2 fixed support, and a ruler.
The control variable for the first objective is load applied, while independent variable is the length of the beam. On the second objective, the control variable is length of the beam, while the independent variable is load applied. Then the dependent variable for both objectives is deflection measured on the beam.
Explanation of expected result. The result we expected before doing the experiment for the first objective is the higher the amount of load applied to the beam, the higher the deflection. For the second objective, the shorter the distance between the two knife edges, the higher the deflection. For the last objective, we expected material 1 is tungsten, material 2 is aluminum, and material 3 is tungsten carbide.
During the experiment, make sure to wear shoes as the loads might fall down. Next, we should be careful around the beam support as it can fall down on us. Other than that, make sure to clean up after the experiment to prevent others from knocking it over and getting injured.
That's all from us. Thank you.